Hello everyone, welcome back to the channel. I hope you are doing great and making consistent progress in your DSA journey. Today we are going to solve one of the most important recursion and dynamic programming problem, that is coin change problem. In this problem, an array coin representing different denomination of the currency and an integer sum, and we have to find out the number of ways in which you can make this sum by using different combination from the coins. And we have infinite supply of each type of coin, therefore you can use any coins as many time as you want. So at first glance you might think that this problem is very simple. We are given some coin denomination and the target sum, and our task is to find out the total number of possible combination that can form the target sum. And there is one more important condition here mentioned, that we have infinite supply of every coin. That means if you have coin value 1, so you can use this coins once, twice, thrice, or as many time it required. Let's understand this with the current example, that is 1, 2 and 3. The three different denomination coin are given there in the coins array, and we have some value that is 4. So we have to find out in how many ways you can make this sum equal to 4 from different combination from the coin denomination 1, 2 and 3. So the first combination is you can use 1 4 times. So this is the one combination. You can use 1 comma 1 comma 2. This is the second combination. You can use 2 comma 2. This is the third combination, and you can also use 1 comma 3. So we have to return this 4 way as an output, that you can make a summation 4 from the different denomination of the coin 1 2 3 in 4 ways. So you have to return this 4 as an output. Before moving further, let's clarify one very important point. In this problem, we have to find out the total combination, not the permutation. So what does it mean? Let's suppose we have take this value 1 1 2. Someone might say that we can also choose 2 comma 1 comma 1. Someone also say 1 comma 2 comma 1. So all these are same. We have to take care of combination, not all the permutation. So these all are considered as one, because in all these container same set of the coins are there. So we have to consider this as only one way, and we have to find out the total combination in which you can find this sum equal to 4. In this tutorial we are going to solve this problem from brute force approach to optimal approach. We have seen the problem statement and now built our intuition to solve this problem from brute force approach. So let's get back to the notebook. This is our coins array and the target, that is equal to 4, and we have to find out the number of ways in which you can make this target equal to 4. Here a coins array is given to us and the sum or the target value, and we have to find out in how many ways you can make this sum or target equal to 4 from the different combination of these coins. Now for iterating this array, coins array, we need one iterator index I that is going to iterate this from index 0 till n minus 1. So we are going to use one iterator, and at every index we have two options. Either we can pick up that coin or we can skip that coin. So we have two options here, either we can take this or skip this. Again at the next index we have two options, either we can take this or skip this. Again at the next option, either we can take this or skip this. So from here we got the intuition that at every index I we have two options, either we can take this or skip this. Now I'm going to take the first way to develop the intuition that how we are going to solve this problem. So let's suppose we are going to consider this example, and currently our index is at index 0, and this is our coins array, and we have the target value that is equal to 4. And at every index we have two choices, either we can take this or skip this. So when we consider this index 0 value, then our target become 4 minus 1 because at index 0 value is 1. So again we have to sustain at the same index because if we have infinite supply of coin and we are going to consider this example, so at every point our index is sustained at 0 because every time we are going to consider the index 0 value. So every time we have to take this value. So after considering this, our target become 3. And again we have two options, either we can pick this or skip this. So whenever we take this, again we sustain at index 0 and this is our coins array and our target become 2 because again we find out the value 1. So now our target become 2. Again we have two options, either we can take this or skip this. So after considering index 0 value, again sustain at index 0 and this is our coins array and now our target become 1. Again we have two options, either we can take this or skip this. So when we take this, now our index is again sustained at index 0 and our target become 0. So here our target become 0, it means we find out one way, and this is the one way in which you can make this target sum equal to 4 from the different combination of this coin. So in this process we every time consider the index 0 value. So currently our target is 4 and when we consider index 0 value, target become 3. Again we consider the same value, then our target become 2. Again we consider the same value, our target become 1. Again we consider the same value, now our target becomes 0. So whenever our target is equal to 0, it means we find out one way. Now I'm going to consider this one, and our concern is that how we can find this one way. So at beginning we are standing at index 0 and we are going to consider the index 0 value. It means our target become 3. Now again we consider the index 0 value and our target become 2. Now we have two choices, that either we can pick the index 0 value or move to the next index value. So here it moved to the next index value, that is index 1, and its value is 2. So at this point we have to skip the index 0 value. So whenever we skip the index 0 value, it means we move to the next index value. That means we move to 0 plus 1 value, that is 1 index. And this is our array, and our target remains same because we have not considered the index 0 value. And now we have two choices at the index 1, that either we can pick the index 1 value or we can skip that 1 value. So here it consider the index 1 value. So whenever we consider the index value 1, we again sustain at index 1 and this is our array, and now our target become 2 minus 2, that is equal to 0. So whenever our target becomes 0, it means that you find out the another way by which you can make this target sum equal to 4 from the different combination of these coins. So here we pick the index 0 value, again pick the 0 value and then skip the 0 value, then pick up the index 1 value, and now your target becomes 0. This means that this is the another way by which you can make the sum equal to 4 from the different combination of the coin. So from here you can see that at every point we have two ways, that either we can take this or skip this. In first example we take the one value, again take the one value, again take the one value and one value. In the second example or the second way, we pick up the first value, then pick up the first value, then move to the next value and consider the next value, and now our target becomes 0. It means that this is also another way. So from here we can conclude that at every point we have two way. So we can say that for every problem we have two subproblem. So from here we got the intuition that this is a recursion based problem. So we are going to solve this problem with the help of recursion. Let's write the pseudocode for this, and whenever your target value becomes 0, it means that you are able to find out one way. So here you have to return 1, and whenever your target value become negative, so here you have to return 0 because it is not possible that your target value become negative. And there is one more edge cases that your I value is starting from index 0 and the last value is n minus 1 and your index reaches the value n. It means that you traverse the whole coins array and your I become n's, but you are unable to find such pair. So here also you have to return 0. So these are the base cases and edge cases. I am going to write down, like if target value is equal to 0, then here you have to return 1. And when target value is negative, then also you have to here return value 0. And there is one more edge cases that you traverse the whole array and your index become n, but you are unable to find such pair. So here also you have to return 0. So these are the base cases, and now we have to write down the recursive function. So let's suppose you are standing at this point and you have two options. Either you can pick this path or you can pick this path. So whenever you pick this path, then you find out this one way. And whenever you skip this path or you can choose this path, then also you find out the another way. So for finding the total number of ways, you have to return via taking the path plus skipping the path. So you have to return the total number of ways via taking the path plus skipping the path. Now let's suppose you take this route. So whenever you take this path, then you have to call the function. Let's suppose the function name is solve. So this is the solve function that take the coins array as the parameter and idx as the index iterator and the target value. So whenever you choose this take path, then you have to again sustain it the same index, and this is the coins array and you sustain it the same index idx, and now your target reduced via coins at that index. So your target become target minus value in coins array at that index. So you have to subtract this value from the target. And let's suppose you have another option that you can pick this path, that is a skip path. So whenever you choose this skip path, then also you have to call the solve function, and here it also take the coins array as parameter. And now whenever you skip this index 0, then you have to move to the next index. So here your index is updated with index plus 1 and your target remains same, because here you can see that your target remains same. You are not going to consider the index 0 value. So your target remains same. And at last you have to return the total number of ways via taking the this path and this path. So you have to return take plus skip. So this is the pseudo code of this code. Now I'm going to implement this code on the code editor. Let's declare the global variable int n, and this is equal to the size of the coins array. Now we have to write down the solve function that is going to give us the total number of ways. So this is the solve function that is going to be take this coins as the parameter and one iterator, and there is one more value that is the target, or we can say it's sum. Now we have to write down the base case. The first base case is that if our target value is equal to 0, it means that we find out one way. So here we have to return 1. And there is one more edge case that if our target value is less than 0, then here we have to return 0. And there is one more edge case that if our index reaches the last value of the coins array, then here again we have to return 0. So we have write down the base cases. Now we have to write down the recursive function call. So for finding the total number of ways, we have to write down the total number of path via taking the path plus skipping the path. So we have two ways, like take the path or skip the path, and we have to return both take plus skip. And whenever we take the path, then again we have to call the same recursive function with the same coins array. And here iterator is not moving to next because we have infinite supply, and our target reduced to value of the coins at that index. And in second function, whenever you skip that path, then again you have to call the same solve function, and here again we take the same coins array, and now here our index move to the next one, so index plus 1, and there is no changes in the target, so this is our target. So this is the code for the implementation of the coin change problem using recursion. Let's compile this code. So here we got an error. So let's fix this error. The error here is we passed the parameter, but we didn't pass the actual parameter. So we have to pass the actual parameter here, and here we have to call the solve function with the coins array, and initial value of the index is 0, and the target value here is sum. Now let's compile this code. Now there is an error in the 27 line. Okay, so semicolon is missing there. Let's again compile this code. Now compilation is completed. Let's submit this code. So after submitting this code, we got an error that is time limit exceeded, because here we use recursion to solve this problem, and in recursion time complexity to solve this problem is big O of n squared. That's why here we got the runtime error. Let's understand the code with the dry run of the same coins array with the value 1, 2, and 3, and the target value is equal to 4. And we are currently standing at the coin 1, and we have two options, either we can take this or skip this. So whenever we take this, our target value become 3. Again we take this, target value become 2. Again take this, target value become 1. Now it becomes 0. So whenever your target value becomes 0, we find out one way. So this is the one way. Now moving forward, we find out the value here is -1. So we traverse and we are unable to find any value, and our target value here is negative. So from here also we have to return 0. Whenever your value is negative, target value is negative, you have to return 0. So from there also you have to return 0. Now moving forward, here we traverse the whole array and I reaches to n, but we are unable to find such pair. So from here also we have to return 0. Now we have to backtrack, and from taking this we find out 0 way. By skipping this we find out 0 way. So we have to return here 0. So 0 is returned here, 0 plus 0. Again here 0 is returned. Now after backtracking here 1 is returned. So this is the way via which you can dry run of the code. And here you can see again the value is 0. So you have to return here one way. So this is the one way. So here again the value is negative. So you have to return 0. So this is the similar way via which you can dry run of your code, and you can find out the total number of valid combination there. Here again it is negative. So you have to return 0. Again move forward. Again value is negative. So you have to return 0. Do the same step and we find out one more ways. So this is the implementation and the dry run of the coin change problem. In the upcoming lecture, we are going to solve the same problem with the optimal approach and the better approach. This is all about the today lecture. Thank you so much.